For as long as we've gazed at the night sky, Mars, the little red dot, has fascinated us. Its distinct red hue has always stood out among the stars, capturing the imagination of dreamers and scientists alike. This tiny speck in the vast expanse of space has been a source of endless wonder and speculation. It's our neighbor, both familiar and alien, and we can't help but wonder what it's like to stand on its surface. The idea of setting foot on Mars, feeling its soil beneath our boots and exploring its rugged terrain is a dream that has driven countless missions and inspired generations. Ancient civilizations named it after their gods of war, drawn by its blood-red color. To them, Mars was a celestial embodiment of power and mystery, a divine presence in the night sky that influenced their myths and legends. Today, our curiosity is scientific. Are we alone in the universe? Mars is the logical place to look for answers. Its proximity and similarities to Earth make it an ideal candidate for exploration. Scientists and researchers are eager to uncover its secrets, hoping to find clues that could answer some of humanity's most profound questions. Billions of years ago, Mars had rivers, lakes, maybe even an ocean, key ingredients for life. These ancient waterways suggest that Mars was once a much warmer and wetter place, potentially capable of supporting life as we know it. Now we see dried riverbeds and ancient deltas, like fossils of a once living world. These geological features are like time capsules, preserving the history of Mars's climate and environment, and offering tantalizing hints of what might have been. This drives us to send robotic explorers, our eyes and hands, across millions of miles. These rovers and landers are equipped with sophisticated instruments designed to analyze the Martian soil, atmosphere, and geology, providing us with invaluable data. Each mission is a new chapter in the story of discovery, searching for clues from billions of years ago. From the first flybys to the latest rovers, each mission builds on the knowledge gained from the last, gradually piecing together the puzzle of Mars's past. The allure of Mars is the possibility of a second genesis, a separate origin of life. If life ever existed on Mars, it would suggest that life is not unique to Earth, but a common occurrence in the universe. Even the simplest Martian microbe would change our understanding of our place in the cosmos. It would mean that life can arise independently in different environments, vastly increasing the likelihood that we are not alone. Mars isn't just a ball of rock and dust. It's a symbol of potential and the quest to understand our origins. It represents the human spirit of exploration and the desire to push beyond our boundaries to discover what lies beyond. The journey to answer these questions is one of humanity's greatest adventures. As we continue to explore Mars, we are not just learning about a distant planet, we are learning about ourselves and our place in the universe.
When searching for life beyond Earth, we don't start by looking for little green men or alien civilizations. Instead, we begin with the most fundamental ingredients, the building blocks that make life possible anywhere in the universe.
On Mars, those building blocks are organic molecules, carbon-based compounds that are essential for all known forms of life. These molecules can form naturally, but they're also the backbone of biology as we know it. That's why NASA's Curiosity and Perseverance rovers are equipped with advanced tools to drill into Martian rocks and analyze their chemistry, searching for even the faintest traces of these vital compounds. In Gale Crater, Curiosity made a groundbreaking discovery: complex organic molecules preserved in ancient mudstone. This is evidence that billions of years ago Mars had the raw materials needed for life to potentially emerge.
These molecules are the foundation of proteins, cell walls, and other critical structures. Finding them in rocks that formed in ancient habitable environments is a huge clue that Mars may once have been more Earth-like than we ever imagined.
But it's important to remember, finding organic molecules isn't proof of life. It's just one necessary ingredient, like finding flour in a kitchen doesn't mean someone baked a cake. Still, it's a major piece of the puzzle. Each discovery helps us understand Mars's history and its potential to support life, but it's not the whole picture. The real challenge now is to figure out where these molecules came from. Were they created by simple chemistry, or did ancient Martian life assemble them? That's the mystery scientists are determined to solve.
The hunt is on, and every new clue, every molecule, every rock sample brings us a step closer to answering one of humanity's oldest questions. Are we alone in the universe?
The cosmic detective work has only just begun. With each mission, we gather more evidence, test new ideas, and refine our search for life's fingerprints on Mars. Each rover, each experiment, and each discovery brings us closer to understanding Mars's true potential for life, and perhaps to finding out if we have company in the cosmos. Finding organic molecules on Mars doesn't mean we've found life. The universe is a clever chemist. Many non-biological processes can create these molecules.
Meteorites, especially carbon-rich ones, have bombarded Mars for billions of years, delivering organic compounds.
It's possible the organics Curiosity found were delivered from space, not made by Martian life.
Geological processes, like volcanic activity and serpentinization, can also create organic molecules.
Mars's ancient volcanic past could have produced these compounds without any biology involved.
That's why planetary scientists must rule out every non-biological explanation first. They analyze the context, where the molecules were found, their complexity, and the environment.
The search for life is a process of elimination, with many non-biological suspects to consider. Our quest to understand Mars began decades ago, when the Viking landers made history by touching down on the Red Planet in 1976. These pioneering spacecraft marked humanity's first successful attempt to land and operate on Mars, opening a new chapter in planetary exploration.
Vikings' robotic arms reached out to scoop up Martian soil, carefully collecting samples to test for signs of life. Anything that might breathe, metabolize, or hint at biology. The landers were equipped with experiments designed to detect even the faintest traces of living processes. One experiment produced a surprising result. When nutrients were added to the soil, a burst of gas was detected. This reaction hinted at the possibility of life, sparking excitement and debate among scientists back on Earth. Was this the evidence we'd been searching for?
Yet other instruments on Viking found no organic molecules at all, creating a puzzling contradiction. The results were both thrilling and frustrating, leaving scientists with more questions than answers.
Years later, researchers discovered that reactive chemicals in Martian soil, like perchlorates, could mimic the signs of life Viking was searching for. These chemicals could break down organics or create false positives, making the search for life even more challenging. The Viking missions taught us a crucial lesson. Searching for life on another planet is far more complex than we imagined, and Mars itself can be deceptive, hiding its secrets beneath layers of chemistry and dust.
For many years, the lack of detected organics put the search for Martian biology on hold. Scientists debated whether life could ever have existed on Mars, or if we were simply missing the evidence. But the Viking missions laid the essential groundwork for all future Mars exploration, inspiring new generations of scientists and engineers to keep searching.
This led to a new strategy. Instead of looking directly for life, we began to follow the water and search for environments that could support it. Rovers like Spirit, Opportunity, Curiosity, and Perseverance have all explored Mars, each searching for clues in the rocks and soil. Each new rover has built on Viking's legacy, carrying more advanced scientific tools and pushing the boundaries of what we can learn about Mars. The case Viking left unsolved is now being reopened with every new mission as we continue our Martian journey, determined to uncover the truth about life on Mars.
Today's rovers are like rolling laboratories, far beyond what Viking could do.
Perseverance's Sherlock uses lasers to spot organic molecules from a distance.
Pixel maps chemical elements in rocks with incredible precision.
The biggest leap. Perseverance collects and stores samples for a future return to Earth.
No rover can match the analytical power of Earth's labs.
Bringing samples home will let scientists search for biosignatures with unprecedented sensitivity.
This could finally reveal if Mars's organics are geological or biological.
The ultimate achievement may be returning pieces of Mars for study on Earth.
If life exists on Mars today, it's not on the surface, it's hiding underground. The Martian surface is harsh, dry, cold, and bombarded by radiation.
The best place to search is below ground, where life could be shielded.
On Earth, extremophiles thrive in boiling vents, Antarctic rocks, and deep mines.
This is the kind of life that could exist on Mars. Simple microbes in protected niches.
Underground briny water, kept liquid by salts and geothermal heat, could be a refuge.
Even a thin layer of soil can protect microbes from radiation.
Future missions may need to drill deep to find these hidden habitats.
The search for life has moved underground, where Mars's secrets may still be alive. What if life on Mars and Earth are related?
The Panspermia Hypothesis suggests life can travel between planets, hitching rides on rocks blasted into space.
Early solar system impacts could have launched rocks and microbes between Mars and Earth.
We've found Martian meteorites on Earth, with gas signatures matching Mars.
If rocks can travel from Mars to Earth, the reverse is possible too.
If we find Martian microbes, are they truly Martian or our distant cousins?
If Martian life uses different biochemistry, it's a separate origin. If it's similar, we may share ancestry.
Finding life on Mars could reveal the true story of life's beginnings in our solar system.
One of the most intriguing clues in the search for life is Martian methane.
On Earth, most methane comes from living things, microbes, cows, swamps.
When Mars rovers detected methane plumes, scientists took notice.
The methane isn't constant. It appears in bursts, then vanishes.
This suggests something is actively releasing and destroying methane.
Could underground microbes be producing it as a waste product?
Their activity might change with the seasons, explaining the plumes.
If true, this would be a modern sign of life.
But geology could also explain it. Serpentinization or seasonal rock fractures.
The mystery of Martian methane is a perfect example of science in action.
We need more data to solve the case.
Future missions will try to pinpoint the source of these elusive plumes. The search for life on Mars is a fundamental part of our drive to explore.
We're driven to answer, are we alone? Mars is our best chance for an answer close to home.
Every rover, every rock, every bit of data is a step forward.
We've found clues. Riverbeds, organics, methane, but no proof yet.
Mars is now a complex world with a rich history, not just a point of light.
This search inspires us, pushes technology, and unites people worldwide.
The quest reminds us we're all crew members on Spaceship Earth, bound by curiosity.
Whether we find life or not, the search will change us.
If Mars is lifeless, it shows how rare and precious Earth is.